I always like to start with what are the transformations?
Mhm.
There are 4. Do you want me to list them or do you want to give it a shot? And the order does
I think
matter
I'd
here.
like to give it a shot.
Okay.
So I'm gonna move. Also, the teacher doesn't like really care how much like order it is in, but like if I make a mistake order wise, just let me know so I can like correct
Okay.
that.
It will matter at some point is why I emphasize it. It's not like
Yeah.
Matthews thing.
If
It's
it's one
like,
at the beginning, it'll
yeah,
be easier. Moves horizontally to the left by 1 unit,
okay, agreed.
flips over the x-axis.
Okay.
It gets stretched by 3.
Vertical stretch. We got to indicate whether it's vertical or horizontal. And these actually can go in either order.
Oh, okay.
I would actually put the stretch first, but it really is either way is okay. And then the
Yeah.
last one is,
Move up vertically by 2 units.
yeah. So I think we did this last time is that the left 2 or the left one affects the x value.
Mhm.
The flips over the x axis that affects the y. The vertical stretch affects the y and the up 2 affects the y. And then we can actually say like we can be more specific here about how it affects each. And you can either do it in words or symbols. So like left 1 means you're going to subtract 1.
Mhm.
Flips over the x-axis, you're going to negate or negative. Vertical stretch, you're going to multiply by 2.
All right.
And up 2, you're going to add 2.
X, Y, Y, Y. So the only time when it's moving,
and that's the variable it affects or the ordered pair. And that's really important because you only know which one you have to manipulate.
Mhm. Okay.
We kind of did this. I think this is a little more organized. Had some time to think on it since we last met. And this is what I came up with that I think will be
Yeah.
helpful to you. So we start with the parent function.
Wait, sorry. I do have one question.
Yes.
So when it has a whole number, like -3, for example, and then the parentheses,
Yes.
that means that you are multiplying the y values by 3, correct?
You, you, I'm sorry. Yeah, it's by 3. I wrote the wrong number here.
Oh
You're
no, it's okay. It's not with that. I was just like double checking.
yeah, yeah,
You're dividing it by whatever that fraction is.
yes.
So if it's a half, it will go from 2/4 to 2 and 2.
Yeah,
Right.
I
Okay.
think so. Yeah. Okay, so let's start with y equals x squared. And
Wow.
and the parent function here, you got to know. You got to be able to like get out of bed and know how
Yeah, I
to do
got that
this.
down. I can say that till the day I die now.
Okay, great, great. Now we can actually do all the transformations at one time, or we can do them one by one. It's up to you. What would you like to do?
Um, you know what? Let's just do it one by one.
Okay. So the first one is left 1. So that's this x plus 1 squared. So that we just wrote up here subtract 1. So all of these x values you're going to subtract 1 from. And you also wrote left 1, so that's also an indicator of what's happening here. So all of these x values, I just moved left 1 by subtracting 1.
Uh-huh.
And then the
Oh,
y
now I
values,
understand how that works because you're moving it over. Okay.
yes,
I understand the meaning to that now.
great. Y values stay exactly the same. No change to those because we're doing them one at a time.
Yeah.
Okay. Do you want us to graph this or can we move past that?
We can move past this.
Okay. So now for the next one, we're now doing y equals, and this is why I prefer to do the number first, because if we do them in the order you have here, we have to do negative x plus 1 squared, which is fine.
Mhm.
It's not wrong. It's just that there's a reason that I present things the way I do. But all you're doing is you're taking the negative of the y values.
All right.
Like this line, this second line here, flip the
Yeah.
x-axis, change the y value, make it negative, or negate it. Because if it's positive, it's negative, it's positive. We just negate all those values. But the x stays the same.
Mhm.
Is that okay?
Yes.
All right, now the next one is that multiply by 3. So it's y equals -3 x plus 1 squared. And hopefully you can see like I'm slowly building to the actual graph up here.
Yeah.
The x values stay the same. We said that the only change for the first one, so they're of course going to stay the same. Now we have to multiply each of these y values by 3.
All right.
Okay, so now we've multiplied them by
And
3.
then has a 3 over there.
Okay,
Okay.
you got that?
Yeah.
And then the last one is we're going up 2. So it's the same x values, but now we add 2 to the y values, every y value.
So that's all having 2 added to it.
Yes,
Right, because it's moving up 2.
that's right.
Okay. Yeah, I don't know why this just somehow did not make sense to me last time.
That's okay. Sometimes you got to see things more than once. You're driving now. I'm sure, hey, you saw your parents drive for years. You're in the car now. It's a little, a little bit different now
Yeah,
that you're.
definitely a little bit different.
Now, I mentioned this earlier, and I would love for you. I like that you want to go step by step here. You can go all the way to the end here. At some point, I want you to be able to make that leap. Like
All right.
you take this 4, you negate it, you multiply it by 3, and then you
Mhm.
add 2. Like you can do all that. You can do those steps. And you can see if you negate 4, multiply it by 3, that's -12. Then you
Uh-huh.
add 2, it's -10.
Yeah, I just wanted to do this for the first one, so it's just kind of like
Of
when I look
course,
at
of
this,
course, of
that's
course.
how it works.
But I'm pretty sure in your test, you actually do have to like graph the intermediate transformation.
Mm-hmm. Yeah, I'll have to.
All right. What is the domain of this thing?
So the domain is like the x/x weird
So,
e
so we see this is read as x such that, and that's what
x.
this line is. X is an element, and the element is this e of the real numbers. So you say all this, but you write just this up here.
Okay. X subtract.
Such that, not subtract.
Such that, sorry.
Such that.
X, such that x is is an element of the real numbers. So then, I guess the range
The
would be
range.
2.
You have it going here, and it always starts out that the thing is an element of the real numbers. And because it opens down, this is very
And
important, because it
the
opens
number
down.
is greater than y.
Say that one more time.
2 is greater than y.
It's y less than or equal to 2. Maybe
Y is less than or equal to 2.
you probably you were saying this, which is correct, but it's not preferred.
Yeah.
And that's my way of saying like don't do that unless you want to get dinged a little bit on your test. The variable is traditionally on the left.
All right. Yeah, I
In
guess I was
these.
just kind of worded like that, and I just didn't know if I was supposed to say like less than. So I was just
Well,
like,
no, this is right. What you
it's
what
just
it's
down. It's not proper.
yeah. I mean, we have words in our language that is just is weird. I don't know. I'm not trying to think of a good analogy here, but I don't know. But it's because it opens down, it's less than. If it were opening up, it would be a greater than or equal to.
All right. Sounds good to me.
Okay, do we need to do 2A?
2A. I think I
Or
let
2B?
me look at this one more time. I think I'm just would be good to move on to it's where it has the brackets. There was this one problem I was actually a little confused on. when you were writing it, it's man, where did that thing go? Okay, so it's like when you write out all of you write the formula for a like the graph. So they give you the graph and you're like, it's man, I'm so
That's okay. Find your words, but if you can also point me to the page,
so
that
it
would help too.
has okay, so it's when it shows the graph, like for example, like Unit 3 test review study guide,
Yes, I see that.
and then it has like just a problem like this where it's A, and then it's like you write out how it moves over, and then like write it all out, and then write the formula. There was a problem like this. I can't find the actual paper for it at the moment, but instead of being like parentheses, it had like just the straight lines.
Absolute value.
Absolute value. I think
Okay.
so how does that exactly work with absolute value?
Okay. Yeah, we can do that. Do you feel comfortable with the quadratics before we move to absolute value?
Yes, I do.
Okay.
I got that down.
Yeah. I actually did a 1-minute video on Instagram on how to graph absolute values quickly.
Oh,
And
sweet.
you might check it out, Tutoring by Matthew. But for your purposes, we'll just start with something kind of straightforward. Let's go with x minus 2 plus 1. Oh, and you're saying you were given the graph or you were given the function to make the graph?
So I had the graph and I just had to make
Got it.
that.
Yeah, so let me do that. I'm gonna just build this in another application so that it looks nice, and then I'll bring it over here to this. Yeah, actually, yeah, that's good enough. Okay. Yeah, and if you ever need a quick question answered, you can always hit me up on social media, Instagram, Facebook, Twitter, Tutoring by Matthew, and be happy to, fill in the blanks. So,
All right, thanks. I appreciate that.
yeah, so this is kind of like, it's kind of like a quadratic. And so this is for absolute value.
Mhm.
And I'm gonna above show what it is for a quadratic. So the difference is that one is obviously square, no square, and then parentheses, and this is absolute value. What they both have is a vertex at h comma k.
All right.
So your vertex here is at 1 comma 2. So you immediately write a x minus 1 plus 2. Do you see that?
Yes, I do.
Now, the way you find a, this is different than what you might see in class, is you actually calculate the slope of the line. What's the slope of this line? Well, you go up 1
And
and
over 2.
over 1. These are by 1. Sorry, they're
Oh yeah, it's fine.
So this is the slope of the line. Okay, so in this case, it's 1. You don't have to substitute a value in. You can, but it's faster to actually just look at the slope of the line.
Mhm.
So it becomes 1 times x minus 1 plus 2.
So then I'm just looking at it. So if you have the 1, move in 1, and then switch. So that minus is making it go to it's like the opposite, right? Because
Yes. Yes.
All right.
Yes.
And then you move it up too.
Yes.
So it's kind of like the same thing, just like different, like I guess bracket thing almost.
Absolute value means you get straight lines out of
Okay.
it. So let's do another one here. We got tons of time, so I want you to actually do this one on your own. I'm trying to help out by giving you that vertex, but it's a x minus h plus k. So this is h and this is k. So this time, and I'm not going to write a yet, but it's x minus a minus 3. And then k is minus 4. Do you see where I got those values from? It's this point.
Yeah, I do.
Okay, now inside parentheses here, absolute value, we're going to write x plus 3. We do deal with that. Now, again, what is the slope? What is the slope of this line to the right?
1 and 1.
It's 1/1. So A is 1. Now it's not always 1. We're going to do a problem now where it's not 1, and you can see that.
All right. And then is slope basically where it just moves up and then over or down?
Right. It's rise over run, rise over run.
And then it has to go to the right.
Yes, it's always to the right.
Okay. In slope, it's y2 minus y1 over x2 minus x1, right?
Yes.
Okay. So it feels like forever since I've done that with you.
Yeah, no, you're going to want to remember that. That's an important formula here. So let me snip in our next question.
All right.
So our next question, here is the vertex.
All right.
And if you're not writing out this formula, you definitely want to, because it'll help you to remember it. The more you use your senses, the more you'll remember things.
Got it down right now. Is it just -1?
Yeah, so this time the slope is not 1, but it's going down and then right 1. So it's -1/1, -1/1. So yes, the slope is -1. And that should make sense because it's flipped, like it's reflected over the x-axis. Okay, now it's not always just 1 and -1, but that's the power of this method that I'm going to show you in this next problem.
All right, so when writing the formula, would I just write negative, then brackets x plus 2 plus 5, or
yes, this is your final answer.
Okay, that's
you cannot. These are like brick walls. You can't. They're impenetrable. That negative has to stay on the outside.
So when I have what are those lines called again?
Absolute value.
Absolute value. Okay, absolute value x plus 2.
Yes.
All right, thank you. So then.
So I'm going to give you a new example here. This one's a little different, but you can do it. It's a little bit, it's intentionally made a little more difficult. So it's not going to be just like fire off the answer. But I know you can do it, and I'll help if I need to. But it's the same process here. You want to find the vertex.
All right, sounds good. Y equals ax. So would it just be x minus 3 in the brackets? Like
yes, yes. What is k?
0.
That's right. So you don't even need to write it. Now, what is the slope here? And be very careful here. Don't just blurt it out. Really make sure you got it down.
1, maybe 3/4.
So you're going up 1. Do you see that hits the 1 there? How far right are you going?
I'm going 1.5.
Yes. So that's your slope.
1/2 x minus 3.
Yes. And that's the power of this method is you literally take the slope and you put it right there. You don't have to fool around with the substituting numbers. You just read it off from the graph.
Shoot. All right. Okay. Just got to get that memorized.
Yes.
So then,
so you want to do another? Let me give you another one here. I mean, I don't, again, I'm going to make these just a little more difficult. You can do this though. This is not like, it's not learning Chinese. Chinese is really hard to learn. But you absolutely can do this. So let me snip this one in.
And then do you think after this one or another one, just how many? Do you think we could do all four types or three types of the like graphs?
When you say all types, what could you just give me a little more information on that? What you mean?
It would be oh my god, I can't remember.
You mean the parent
This one,
functions?
yeah, the parent functions. I don't know why I can't get
Okay,
that.
yeah, we'll get to that. So go ahead and give me one. Give me this. This is kind of your exit
Um,
question. If you can do it. Um,
X minus H plus K. Okay, so okay, so I'd say I have all of it, but the slope.
okay, well, you got to pick another nice point down here. Yeah, I think I gave you enough here. So here's your other nice point. So how far down is it? How far right is it?
Okay, so for why'd you choose that spot exactly? Like, I'm just kind of curious.
It's nice. I know this thing doesn't like this is at -1.
Oh,
That's why I chose it. Like you could choose. I guess I didn't get. So I only gave you that much. That's the only one you could reasonably choose for this
yeah,
one.
and that's fine. Like, I don't need more. I was just like curious. So that's like just would make most sense, most quick, like most
Yeah.
logical.
So how far down, how far right? And remember down is negative. So your
Mhm.
slope here is going to be negative.
Negative. So then you're going down -3.
Down. I'm sorry. What did you say?
You went down 3
Okay. And then what?
to the right by 4.
Okay. So what is that? What is that here? What goes here?
1/2 because if it's 2/4.
Did you said down 3?
Oh, 3/4.
Yes. -3/4.
So then -3/4 absolute value x plus 2 plus 2.
Yes.
Okay.
Okay.
So
Now
the fractions will make it go out more wide. So
that's
that's stretch.
okay. That's only if it's the number is less than 1 without the negative sign. It makes it go out wide. Because if I make it like 6/5, it's going to be narrower.
Yeah.
But I don't think you'll see that. Yeah, that you got to be careful with those general blanket statements.
All right. -2 x plus 2 plus 2. And then when it's a whole number, it will make the numbers multiply by that number.
Yeah, like the type of problem you have to be comfortable with is finding the vertex, putting that in for h and k. Boom, you got it. Then the slope to the right. You always go to the right, not the left. Just ignore the left. You don't care about
Yeah.
that.
You always
And
do
you
it.
and you could do rise over run. So if it goes up, it's positive. And their slope goes right there. So in the next one we did, there's also one, but then I said, hey, look, it could also have a negative slope. And then you just put that negative number down there. Then we talked about it having a fractional slope, which is totally possible. And you're right, it does widen it. So those are all the things you can be on the lookout for. But you got to get H and K. That's for sure.
Yeah. Thankfully, H and K is the easy part.
Right. Now, by the way, what's the domain of this last one?
It is. I can't remember that fancy ending to it, but do you want to know the range?
Yes. I want you to give me the right range here. I don't care if you say the right things. I want to get the right part over
So
here.
y is less than 2.
Less than or equal to 2, because you can go up right up there and hit it.
Okay.
So it's less than or
Less
equal
than
to.
or equal to 2.
Yep. Now, how
Is there
about
times where it would be an equal symbol instead of like the arrow pointing at one number to the other?
These are always going to be greater than or equal to or lesser than or equal to.
All right.
How about this one here? What's the range of this one?
Um,
And again, I'm just interested in that last part. You always write this.
that would be y is greater than 3 for this one.
So here's 3. 3 is up here.
Oh, then 0.
It's 0. It's always the k. This is always k.
Right. Okay. Yeah. I don't know why that didn't click.
See how that's k? It's always k.
All right. I guess, is there that one up there? Oh no, we already did that one.
Yeah, we do another one here. We'll do this one here. What's the range of this one?
The range of this one is y/y er.
Right.
I'll remember that.
Yeah. Just give me the last part, the inequality.
Y is less than or equal to 5.
Perfect. And last one here. How about this one? Here's your y value.
Y is greater than -4.
Greater than or equal to -4.
Yeah, I'm kind of mad at myself for like a couple months ago. There's like kind of something like this where it's like write the domain and range. It's like so easy, and I messed up on those. Like it's literally just know the formula.
Yeah. But and a lot of school is like that. The instructors literally just want you to regurgitate what they told you. Like they want to believe that you understood it, but that's their next best thing. Like can he write it down in a testing environment? And you can definitely do this. So what I heard is you want to look at the parent functions, and you tell me if this is wrong or this is right. These are the 4 that you were asking about.
Yeah. And then really, I feel like the only one we didn't go over was like y equals x without any other stuff to it. Is that where it's just a straight line?
Yeah, so let's look at why, because they do ask this one, and it's really odd to me that they ask. So they'll do this. They'll say y equals. Oops, I just did that. They'll go 2x minus 1 plus 3.
Okay.
Okay, this is one example. This has 3 transformations. So let's look at them.
Moves to the right 1.
Okay, right 1.
Moves up vertically 3.
Okay.
Final, and then you stretch by 2.
Vertical stretch by 2. Yeah. Okay. So this right 1 affects the x, the vertical stretch affects the y, and the up 3 affects the y.
Wow. So this one's really is just like a straight line.
Yeah. Now you're going to see some things here, but we're gonna do this. So the parent function says y equals x, x equals y. Whatever x is, that's what y is. Whatever y is, that's what x is. They are the same. And that's why when you graph it, it looks like.
It's so weird that they didn't teach us this.
I think they might have thought you already knew it, but we'll just go through it. So right 1 affects the x. So what are we doing to the x if we're going right? If we're going, see how like this point's going over here. This
1, 0, 1, 2, and 3.
You're adding 1 to it. Yeah. Okay. Now this next one says you multiply the y by 2. And we're talking about these numbers here. You multiply it by 2 and then you add 3. So if it's easier, start at the positive ones. 2 times 2 is 4. Up 3 is
12.
7. Up 3 is adding.
I don't know why I'm multiplying that again.
Multiply.
And then 2 times 2 is 4.
No, this one right here. Yeah.
Oh, 2 times 1 is 2 plus 3 is 5.
Yes.
1 times 1 is 1 plus 3 is.
We're doing this. We're not using these x values.
Oh, okay.
So I think that's the mistake here. You already dealt with x. You're just dealing with these y values now. So you take this 0 and you multiply it by 2.
Take the 0, multiply by 2.
It's these 5 numbers you're doing this to, not the x. You already dealt with the x.
S- Okay, here, wait 1 sec. 3. 1 is 3.
There is no one. We already did one.
Okay, I think I'm a little bit confused. Do you think you could re-explain?
Sure. What is the first transformation?
The first transformation is move to the right by 1.
So does that affect X or Y?
That will affect X.
Okay. So you just gave me those values. It's -1, 0, 1, 2, and 3. So you're done looking at the X column. You don't look at it anymore. You're done. That's all that affects X.
Yes.
So now we're just looking, and I'll do this with colors because we're just looking at the blue numbers now.
Mhm.
Just looking at the blue numbers now. So the first Y value, you multiply it by 2 because that's what a vertical stretch does. Then you add 3 to it. And I was telling you, it's okay if you start at the bottom. Like you don't have to start with the negatives.
Oh, okay. So then you have 7.
That's 7. Yep.
Then 2 plus 3 is 5.
Right. And then you go here, 0.
Plus becomes 3.
That's right.
-2 plus 3 is 1. And then -2 plus 3 is what? Wait.
-2 times 2.
Oh, it's 4 plus 3 is -1.
Yes.
And it's all going.
Now you said this before, you said it's a straight line. Well, yeah, it's still a straight line. It has to be. So these have to have the same
Amount
difference.
of distance from each other.
Yes. Yes.
It's kind of funny, like out of all these, I feel like the easiest one, which is this one, is the one I had the most trouble with.
Well, it's, and I'm going to show you something here that's going to, I think, kind of, I hope it doesn't add to the confusion. I really want you to see that, like, it's not, but they're, well, maybe I don't want to show this graph. Your transformations here are correct, but if you were to distribute this 2, and then you combine like terms, like let me come down here and write y equals 2 x minus 1 plus 3. So let's say you distribute this 2, and you're at y equals 2x minus 2 plus 3, and then you added them together. Okay, there are now 2 transformations for this. There's a vertical stretch by 2, and then up 1.
All right.
And this, because it's a line, what we just wrote is equivalent to these 3 here as well. So with a line, you're actually, there's only so many things you can do with a line. You either, but they sort of try to hide it with this, but you're not. My point, I guess, is you're not really doing all these transformations. You're really only doing these 2, but they sort of encode it in this weird problem like this.
Yeah.
So let's do another one here, because I think the mistake here is to try to think this is more complicated than it is. So let's say this is your problem, and they want you to list the transformations. There are 2 transformations here. What are they?
It will be getting shrunk by 1/2, and
So
moving down vertically by 3.
Vertical shrink 1/2, and then down 3. Does the vertical shrink affect the X or the Y?
It affects the X. No, I mean
it affects that X, but in terms of the order, it's a Y. It affects Y only.
Yeah, Y, and then the other one.
The other one also only affects Y. So the only time X is affected, the ordered pairs in the table, is when it's a left or a right, as far as you know, as far as you're going to see.
Yeah.
I'm hearing some hesitation there. Like, yes, this affects that X right there, but X is just a variable. So what does it do to the y value? What does 1/2 do?
1/2 will
Divide by 2 or multiply by 1/2.
mhm.
And then down 3, you're going to subtract 3.
So then, all right, wait, my question is for this is, you know how the other ones have like 0, 0, 1 and 1, then 2 and 4?
Yeah, we're going to have all that.
What's the like base for having a straight line like this?
Okay, yeah, I did this in the previous one, but it's these 5 values, but they're exactly the same.
Oh my gosh, yeah. Okay, wait, never mind. That was kind of a dumb question.
No, it's not, because you need to know the parent graphs for all of these. Like, you're going to get into a class someday and they're going to say, draw something, and you're supposed to like know this without writing it down. That's how well you have to know it. So until it's clear, just keep saying it or doing it,
Oh,
saying it, doing it out loud, whatever you need. Okay, so now is X affected?
no, why is?
Nope. So we just use the same X values. What do we do to the Y values? We multiply it by 1/2 and then subtract 3.
Subtract 3. That's because the problem has 3.
It's down 3.
So then you will multiply by 1/2. So then you'll get,
So it's like -2 times 1/2. That's this one here.
is that
Again,
just become positive 1?
-1.
-1 minus 3 is -4.
Very good.
And then -1 times -2 is -2 minus 1 is -3.
No, it's 1/2. You're multiplying by 1/2.
Mm-hmm. So
So
then,
that becomes -1/2, and then you subtract 3.
oh, -2.5. So then that would mean,
This is actually -3.5 or -7/2.
okay, -3.5.
Yes.
So I'd write it as like a decimal.
Sure, or fraction. It doesn't really matter. But you gotta be comfortable either way.
All right, and then 0,
0 times 1/2 is
0
0, and then you subtract 3.
minus 3.
Yeah.
So in this case, instead of 0 being 1, it's the number that the y is.
Instead of 0 being, I didn't follow that. I'm sorry.
So usually like on this, it's like 0 is 1. Is for this type of problem, is it just whatever the y is?
Yeah, I'm sorry. I'm really sorry, Zach. You keep saying the 0 is 1, and I'm not following. I'm really trying hard here.
Yeah, so like let's say on a different problem, like the different type, like a different type of
Well,
family.
is there one that we did here where it's like that? I mean, the quadratic is 0, 0.
Okay, yeah, I don't know why I just said that. That was like
That's okay. That's why I didn't understand. So I kept asking. I'm not sure.
Yeah, they're all 0. Okay.
Now, not all of them. 2 to the x is 0, 1.
Okay, yeah, that was, I don't know what I was like doing there. Okay, 0 is -3. So then if instead of the problem being down 3, if it was down 10, then it would be 0, -10.
Sure. Yeah. Now, so this next point, you multiply by 1/2,
So 1.5
but this time you
minus
subtract 3,
is -2.5. So -2.5.
right?
2 times 1/2 becomes 2.5 minus 3 equals,
2 times 1/2 is just 1, and you subtract
yeah,
3.
yeah, 1 minus 3 and then minus 2. So as you can see, it's all just moving down by 0.5, all keeping it in a straight line.
Yes. So your new graph, it has this, whatever this looks like, when you go and graph it. And I think you will be asked to graph it. So, you want to, like, we don't want to overcomplicate these. So try your best to not do that. They also, I think, ask some things on here, like what is f of 0? And then they also ask, when does f of x equal 0? Have you seen anything like that in class?
Um, Maybe it looks a little bit familiar to me. Oh
Okay.
wait, I think we actually did that today.
Right. So let's close out with
Like
that.
there's a number.
We've got 5 minutes. Let's make sure we get everything. So let's say this is given, which we just looked at. And let's say it wants two things. It wants f of 0. And what this means is put 0 in for x. Okay, so what is f of 0? You almost want to say it out loud. You put in 0 for x.
Uh-huh. So then
So
it's
so you have to simplify. What is 1/2 times 0?
0
Minus 3.
minus 3.
Yes. So what this is the y-intercept.
Mm-hmm.
And you need to know this. Like you need to like reconcile this between now and whenever your test is or quiz. Okay. Now the other one is they want to know when f of x equals 0. Okay, and this is different. Do you visually see that these are not the same?
Yes.
Okay, so this one is to make or replace, I'm gonna use that word, replace f of x with 0. So if f of x equals 1/2 x minus 3, this whole thing becomes 0. Do you see the difference? Like in one, you put 0 in for x. Here, this whole thing becomes 0. Basically, the side becomes 0. See how that side is 0?
Yeah.
And then you solve for x.
Okay.
So you add 3 to both sides. Stay with
And
me
then
here. We're almost there, yeah. And then multiply by 2.
okay, so I kind of did something like this today where it's here, you know what? Now,
Yeah, but this is very important. This is the x-intercept.
is there another way to do this?
No.
Okay.
And you will get this on your test. Like I've seen your class for years now. You will be asked to do this. So we've got time to do at least one, maybe 2 more problems. But do you just need like 30 seconds to like close your eyes and kind of like reset here? Because it's important we get this down in the last few minutes if we can.
All right, let's do this.
Okay. So like this is critical. You've got to know like there's thing 1 is I put 0 in for x.
Mm-hmm.
Thing 2 is I set it equal to 0. And they sound the same, but they're different. It's like asking, well, what's a walk side and what's a sidewalk? They are not the same.
Yeah, they're different.
They're different. So and that's kind of what's going on here. So let's say your f of x equals 4 minus 2x. Okay. And I want part A is going to say find f of 0, and then it's going to say interpret. So this means put 0 in for x.
Put 0 in for x. Okay.
Do you see how that goes in for x?
Yes.
And then you simplify.
4 minus 0 equals 4.
Okay, and I told you this earlier. This is the y-intercept.
Mm-hmm.
So when x is 0, which is what you just did, y is
4.
4, and that's your y-intercept.
Mm-hmm.
You have to say that when it says interpret, you need to either write that word or say that 0, 4 is the y-intercept.
Okay.
Part B will say, where does f of x equal 0? And interpret. Here is f of x. I'm writing f of x again. It's the same as above. This time, you're not putting 0 in for x. This whole thing becomes 0.
Four minus 2x.
Visually, can you see the difference? We put 0 in here, and then we simplify. On the left side, now we have to solve.
Solve for x. So then that'll get you f
F of x is gone. It's just 0. It's just 0.
Okay.
That becomes 0.
So then you have to get rid of the y away from the x. So then you have -4 equals -2x,
Good. Divide by -2, divide by -2.
which would leave you with +2.
Yes. And I told you this in the previous part. I said, this is the x-intercept. So when it says interpret, you better say x-intercept, which
Okay,
is 2, 0.
2, 0. I don't know. I did something kind of like this today.
Yes. Well, it's going to make more sense. It's late. You got other things on your mind, I'm sure, besides just math. You did a great job.
All right,
If
thank
you have
you.
time before your, test or quiz, schedule another lesson if you need to, but I'll send you the notes here shortly. You got the screen recording. Maybe just watch the last 5-10 minutes, if
All right.
anything. And I'll see you next time. Thanks so much,
All right.
Zach.
Thank you, Matthew. See
Have a
you
great,
later.
have a great night. Bye now.
You too.